Welcome to Metrology lecture series. In the present video, we will discuss the measurement of various elements of the screw thread. To check the accuracy of a screw thread, the following elements must be measured, that is, major diameter, minor diameter, effective diameter or pitch diameter, pitch, flank angle and the thread form. First, we will discuss the measurement of major diameter. In general, major diameter of the screw thread is measured by the ordinary micrometer or the bench micrometer. First, we will discuss the measurement of major diameter of the screw thread by using the ordinary micrometer. In the schematically, you have to observe that one. So let's consider the screw thread which having the outer diameter is the capital D, and this is the ordinary micrometer. A micrometer can be used to measure the major diameter of an external thread, and ordinary micrometer is used as a comparator, not for a direct measurement. So in the ordinary micrometer, here we are comparing the outer diameter of the screw thread with the help of the setting gauge. Let's see the procedure how to measure the major diameter by using the ordinary micrometer. First, to take the standard cylindrical rod, in general that is calling as the setting gauge, and the size of the setting gauge is, let's consider capital S, which is the approximately equal to the thread diameter. After that, we have to measure the setting gauge using the micrometer. Then note down the reading. This reading is, let's consider the D1. Next, we have to measure. After taking the readings of D1 and D2, next we have to find out the major diameter of the thread, that is the capital D, by the following relation, that is capital D equal to the capital S plus or minus D1 minus D2. Here capital D is the major diameter of the thread and capital S is the size of the setting gauge, and D1 is the micrometer reading on the setting gauge, and D2 is the micrometer reading on the thread. While measuring the major diameter of the screw thread by using the ordinary micrometer, there is point contact exists between the thread crest and the measuring anvil. So in this regard, you have to apply the very light pressure. The micrometer ratchet should not be used because an excessive forces can deform the crest and introduce the measurement errors. Next, we will discuss the measurement of major diameter by using the bench micrometer. So this is the schematic representation of the bench micrometer. So while measuring the major diameter by using the normal micrometer, so which face the certain problems, that is the different pressure applied the each time. So for the every time of the measurement, there should be a different pressure is applying, then it will take the certain errors, and moreover, so errors will be taken due to the thread pitch, and each and every time there should have to fix the 0 point, otherwise it will be take the zero setting errors. To avoid these errors, we have to go for the bench micrometer. Now question it will be rise, why the bench micrometer is better? So here we are using the fiducial indicator. So here fiducial indicator. So this fiducial indicator ensure the same pressure at every time. So with the help of the bench micrometer, we are applying the constant pressure for the every time of the measurement. And moreover, it is the consisting of the vernier scale which can be measured up to the high accuracy, that is 0.002 mm accuracy. And moreover, so it will be works like a comparator which has to be reduce the errors of the normal micrometer. Next, we will discuss the procedure to determine the major diameter by using the bench micrometer. And this procedure also similar to the ordinary micrometer. So let's see the procedure step by step. So first we have to take a setting cylinder, so which is the nearly approximate size of the thread diameter. So next we have to place this setting cylinder between the anvil, then note down the reading. Let's consider the R1. R1 is the reading with the setting cylinder. Then you have to replace it with the threaded workpiece and note down the reading is the R2. Here R2 is the reading with the thread workpiece. After that one, workpiece is held by the hand. Then major diameter, that is the D major, will become the D plus or minus R2 minus R1. Here D is the setting cylinder diameter, R1 is the reading with the setting cylinder, R2 is the reading with the thread workpiece. Next we will discuss the measurement of major diameter of the internal thread. So previously we discussed the major diameter of the external thread by using the ordinary micrometer and the bench micrometer. So now we have to see the measurement of major diameter of the internal thread. So while the measuring of the internal thread is somewhat difficult then compare with the external thread, because in the internal thread is inside, so it is not easily visible, and moreover it is very hard to assess the thread surfaces. In this regard we have to use the some specialized instruments, that is the thread micrometer. So with the help of the thread micrometer we have to determine the major diameter of the internal thread. So this thread comparator is consisting of the ball ended tips. So in the schematic also you have to observe. So these are all the ball ended tips. Also we are calling as the stylus. So which having the small enough to diameter to enter the thread. And this is also consisting of the dial indicator to take the readings. And another one is the spring loaded floating head. So which has to keep the proper contact. Next we look for the procedure to determine the major diameter of the internal thread by using the thread comparator. So first one is the set the instrument. In this regard, we have to take a cylindrical standard rod and its diameter should be approximately equal to the thread's major diameter. After that, we have to measure this cylindrical standard rod and note down the reading is the R1. Next step is the measure the thread. After that, we have to insert the ball ended tips into the internal thread roots. In this regard, spring applies the pressure to ensure the proper contact. Then you have to note down the reading in the dial indicator. Let's consider this reading is the R2. Then major diameter of the internal thread will become the capital D plus or minus R2 minus R1. Here capital D is the diameter of the standard rod and the R1 is the dial reading on the standard and R2 is the dial reading on the thread. Next we will discuss the measurement of minor diameter. Minor diameter of the V screw thread is measured by a comparative method using a floating carriage measuring machine and the two small V pieces. In the schematic you have to observe. So this is the floating carriage measuring machine and these are all the V pieces which are having the two number of the V pieces. So in the coming lecture we will discuss the briefly regarding the floating carriage measuring machine. But here we have to discuss the procedure to determine the minor diameter by using the floating carriage measuring machine and the small V pieces. A floating carriage diameter measuring machine is a bench micrometer fixed on the movable carriage. This carriage can move at the right angles which is the perpendicular to the axis of the center using a V-ball slide for smooth and accurate movement. And the V pieces are the touch the root of the thread and they are made of the hardened steel for the accuracy and the durability. And moreover, these V pieces ends have the radius which is the less than the root radius and included angle also less than the thread angle. Next we will discuss the procedure. The threaded part is fixed between the centers of the instrument. So first we have to fix this V screw thread workpiece in the centers of the instrument. Then V-shaped pieces are placed on both sides of the thread, and also we should have to ensure that this should have to touching the micrometer anvils and take the reading. Let consider this reading is the R2. So here R2 represent the micrometer reading on the threaded workpiece. After that, the threaded part is removed and replaced with a standard cylindrical gauges, which is the size is nearly equal to the minor diameter of the thread. Then the micrometer reading also we have to taken again. Let consider this reading is the R1. Here R1 is the micrometer reading on the standard cylindrical gauge. Then minor diameter of the thread will become the capital D plus or minus R2 minus R1. Here R1 is the micrometer reading on the standard cylindrical gauges and R2 is the micrometer reading on the threaded workpieces. Then capital D, that is the minor diameter, will become the diameter of the cylindrical gauge. So here minor diameter of the thread is the D plus or minus R2 minus R1. There are some other procedures also there to determine the major diameter as well as the minor diameter of the screw thread, that is the profile projector and the tool maker's microscope. So we will be discuss these methods in the coming lecture series. So by projecting the thread on the screen, if the threads are very sharp or have the node radius at the root, the measurement of the minor diameter is done by projecting the thread form on a screen and comparing it with standards or making the use of the tool maker's microscope. So this minor diameter as well as the major diameter we will be determined by the profile projector as well as the tool maker's microscope. Next we will discuss the measurement of minor diameter for the internal threads. There are the two methods are there. First one is the taper parallels. So in the schematic you have to see. So this is the schematic representation of the measurement of internal threads by using the taper parallels. In the schematic you have to observe. So there are the two pieces which having the wedge shaped pieces. So let's see. For measuring the diameters less than the 200 mm, taper parallels with a micrometer are commonly used. So this method is applicable for the which diameter should be less than the 200 mm. And these taper parallels are two wedge shaped pieces with parallel outer edges. So in the schematic you have to observe. So there are the two parallel wedge shaped pieces are there and their outer edges are the parallel. So when we have to slide them over the each other, the distance between their outer edges is changes. So when I have to slide the one over the other, this distance it will be changes. Let's see the procedure. First you have to place the taper parallels inside the threaded hole. Then you have to adjust them until they touch the inner surface or minor diameter. So first you have to insert these taper parallels. Then you have to adjust. So by sliding the one over the other, then it will be touch the inner surface or the minor diameter of the thread. After that, we have to measure the distance across the outer edges using a micrometer. This measured value helps to find the minor diameter of the thread. So let's see the another method, that is the rollers and the slip gauges. So in the schematic I have to observe. So here I have to determine the minor diameter of the internal threads by using the rollers. There are the two rollers and with the help of the slip gauges. So let's see this method. So this method is used to the diameter are the greater than the 20 mm. So it should be applied. So which the diameter of the thread should be greater than the 20 mm. So less than the 20, we can't be able to apply this method. So first we have to small precision rollers are placed inside the threaded hole. Then slip gauges are inserted between the rollers until they fit tightly and make them contact. After that, measure the total length of the slip gauges. Let's consider here small x is the length of the slip gauges. Then minor diameter will equal to the length of the slip gauges plus 2 into roller diameters. So this minor diameter will become this roller diameters plus this length of the slip gauges. Then minor diameter equal to the length of slip gauges plus 2 into roller diameter. So this is the procedure to determine the major diameter and the minor diameter with the help of the different methods. So thank you.